I see some people in the chat already saying hi before the show starts.
Hello.
Let's give us a couple of seconds here. Ooh, someone from Greece. Oh, Ionis, I recognize you.
Oh, I think you might have sent in some suggestions to me for this this path,
Oh, yeah.
Ionis. And
Okay.
they were very helpful, so thank you. Keep them coming.
Cool. So we are live. Yeah, so Sophie, you want to kick it off?
Sure, yeah. So welcome everybody. This is a 8-week series that we're starting today, going through the new Master Statistics with Python skill path. But this live stream series is going to be done off platforms, and we've provided a bunch of code for you to download and data sets. So even if you're not if you don't have a Codecademy Pro subscription yet, like you can still participate in all of these, and we really welcome anybody who wants to join and learn a little bit of statistics. I'm really excited for this. Alex can confirm that I've been excited about this for a while.
Yeah, this has really been Sophie's like baby that she's been working on for the past couple of months.
Yes.
Sophie, I know that this is like the content that you've been wanting to write for a long time. For folks watching live right now, so we are live on a couple of different platforms. Sophie and I are going to be watching the YouTube chat primarily. So if you're watching on Facebook or Twitter or Twitch, come over to YouTube if you want to chat with us. If you're watching this in the archives, we're going to be so we post all these on YouTube after the fact. If you're watching there, we are streaming these Tuesday afternoon, 4 p.m. on the East Coast, and we're going to be doing it for the next 8 weeks. We're going to be doing this stats series. So if you want to watch us live, hopefully you can join us then.
Yeah. Are there any other housekeeping items, Alex, that I'm forgetting before we get started?
No, I don't think so. I think, people in the YouTube chat right now, we want this to be super interactive. So feel free to say hello to us, where you're coming from. We have someone from Greece, which is pretty cool. And then, Sophie, before we get actually started, I wanted you to talk a little bit about what is this path about? Why are you super excited about this content? What makes this content special? Can you kind of give us a preview of the like overall thing before we dive into the first lesson?
Yeah, totally. So this path, and I'll also add, this path is not done. So I'm actually working on even more content that's going to go into the path in the next couple of months. But this path is all about how to take a look at some data and make sense of it. We're calling it statistics, but I feel like there's a lot of different names that you can assign to essentially the same thing, right? Like statistics, data analytics, data science. All of these fields are focused on essentially trying to be like a sleuth and make sense of a data set when you have a lot of information and you need to condense it down somehow, and use it then to make some sort of decision a lot of the time, or maybe understand something better, like how a process works. And so, so this content is really about the full process of we're going to work with tabular data, which is basically just data that's organized into rows and columns, and just taking like a large data set that is kind of unwieldy, that we can't make sense of by just looking at it, and then turning it into something that we can actually do something with.
I would say, would you say that it's fair to even say that this is kind of this could be a replacement for your like intro level stats course, or you're covering concepts that traditionally are taught in an intro level stats course in like a really mathy kind of way, and instead we're going to start looking at them from this simulation based approach, this like almost less math and more like conceptual understanding.
Yeah. So a little background on me. I taught high school math for 4 years. And then I also taught at the master's and PhD level as like an assistant throughout my master's degree. And I've seen a lot of different statistics classes, a lot of different math classes for that matter. And I feel like a lot of them really focus on this kind of rote, like you do this, then this, then this, then this kind of steps. And a lot of times that makes it hard to remember in the future. So I've heard a lot of people say like 10 years down the line, they don't remember anything they learned in their statistics class. And so later in life, it was kind of presented to me in this different way, and really focusing on conceptual ideas using programming. And I think that while there's a little bit of a hump to get over in terms of understanding some of the programming concepts, I think that overall it makes it easier to understand the concepts and easier to remember into the future. So, and the other thing I'll say about that too, really quickly before we get started, is that throughout this entire series, and if you're working through the path, we're working in Python. There are some like syntactical things, like just how you write code, that you're gonna have to learn in order to implement what we're doing in Python or in any programming language. But what I really want to focus on over the next few sessions is just like the concepts and why we're doing what we're doing, and not necessarily the syntax. I know there's like 6 different ways to do anything you might want, and with varying levels of complexity and whatever. But I think the more important thing is understanding what you're doing so that you can do it in any language that you might encounter, or any software that you might need to use in a job, for example. So
yeah, I actually think that it's a good example of like how to use Codecademy effectively, because a lot of times I think folks will like memorize how to call a function or write a function or whatever, and like not learn the thing behind that, or like not see the big picture, because they're just like learning syntax and like, oh, I got this syntax, which means that I know the thing. And I think what's cool about this course is that the syntax is like a means to an end, where it's like it's almost okay if you don't entirely understand the syntax, where the thing that we want you to understand are the statistical concepts that we're demonstrating through code. So this is, I think all of that is to say that this is very intro friendly. It's totally fine if you don't know how to code or you don't understand the Python syntax that we're using. Really focus on these stats concepts that are being taught here.
Yes. Okay, I'm going to get started without further ado. Cool. I'm going to share my screen. And you guys are going to get to see my whole desktop, which is very exciting.
And a dog.
And a dog. This is my dad's dog, Juno. Also, just so you know, I'm going to be looking up to the side every once in a while because I've got the chat on another screen. And so I'm just keeping an eye on things over here as well. So if you see me looking to the side, I'm not lost. I'm just checking on you. Okay, so, and pulling over some windows. So if you saw the blog post, or hopefully I think on the YouTube link as well, there's a link to this GitHub repository. And yeah, and within this repository, I'm going to add the code and data for every single session in here, and we're going to start with number 1. And so if you click into that folder, you'll see the starting and ending code and the data file that we're going to be using. If you're interested in coding along, I just want to say a good idea would be at this point to just, if you have GitHub up and working, you can just clone the repository. If you don't know how to use GitHub, that's totally fine. Just download this whole repository as a zip file, and then you can double click it to unzip it, and then you'll have all of the files on your computer, so you can just open them right up along with me if you have downloaded Anaconda as well, which I think we also noted on the instructions, but worth doing.
There's some setup required if you want to code along with us. They're described in this README here.
Yes. Okay. All right. With that said, I am going to demonstrate. The reason why I'm sharing my full desktop is that just in case anybody wants to kind of do their own analysis later, I think seeing the full process of how I'm organizing my files and how I'm opening, how applications is just useful. It might seem like silly, but I don't know, that's what I wanted when I was first learning.
Yeah, I think one of the things that's really difficult when you're first starting is like, where are my files going? How do I open them? One of the benefits of Codecademy is that we do that all for you. But then once you try to start doing things on your own machine, it can feel overwhelming. And so demoing that is useful.
Right. So yeah, so I just have this folder, which is exactly what you'll get if you download that whole file. I also saw someone ask about Miniconda. I think that will work. I'm not totally sure. I imagine, yeah, we're not using anything fancy. Okay, so I'm going to go ahead and actually open up my Anaconda Navigator because I like to do things not from the terminal. You can also open a Jupyter Notebook from the terminal, but I like this nice interface. And then what I'm going to do is I'm going to launch a Jupyter Notebook because we're working with Jupyter Notebooks. And of course, it loaded over there. So I'm going to pull this over here. Okay, so now this just gives me my file structure on my computer, and I'm going to navigate to the file that we're working with today, or the folder that we're working with today, and that has all of my code and the data set that we're going to be using. And then I'm going to just open up this starting code, and that will launch a Jupyter Notebook, which is essentially just, it's a code editor, but it allows us to run code and see the output, and then like run some more code and keep all the output on the same page. And it also renders like Markdown. So essentially I can write regular text and not just code.
Yeah, it's a nice way to kind of integrate regular text with code. You'll see like a lot of reports being written up in Jupyter Notebook because it formats really nicely.
Yeah. And one thing I'll note is that I chose this data set and I downloaded it from the UCI machine learning repository. And you can get to that repository with this link. I swear, like they don't pay me for this, but I think that this is a really good resource if you're looking for data sets to just work with as you're getting started as a statistician or in data analytics. It's really helpful to just mess around with some data. And if you're looking for a variety of data sets with different levels of cleaning, I think this is a really good place to look. The other thing I'll mention, so this is the link to the data set. The other thing I want to quickly mention, just in case anybody is trying to like reproduce this from the very beginning, is that this data set, which is the processed Cleveland data from here, is in this like weird format. It's in a .data format. And before uploading it, I changed this to a CSV. And I also added the column names, which weren't in the data set itself, but that I got from from here. So yeah. So just as a side note, I won't go into too much detail, but if you download the data directly, it's not going to be in quite the right format, which is why downloading it from the GitHub will be a little bit easier.
Yeah, it's kind of a good lesson already on just like different levels of cleanness that a data set can come in, where part of what we're going to be doing in this lesson is seeing like, oh, isn't this weird? Like this column is represented as a string where we really want it to be integers and we need to fix that. But even before we get to that kind of step, doing things like this data is coming in a weird format, and it would be really nice to have the label, the labels of each column on this before I even start working on it. So, all data sets come in varying degrees of like neatness or usability for what you're trying to do with it.
Yeah, exactly. And I will also say, like, knowing what to do with a .data file is not something that I just like know how to do. When I first was looking at this data set, I downloaded it. I looked up ways to load a .data file in Python, and then none of them were working, like it was breaking down. And so I Googled what to do and found something on Stack Overflow that said, like, turn it into a .txt file, then turn it into a .csv file on your desktop. And I just followed the instructions. So that's another, like, just general note, is that we're going to go through this, but even we don't always know exactly how to solve every problem. And what I do is I spend a lot of time on Stack Overflow, just like looking for other people's solutions to problems. So cool. Okay, so we're going to get started with this data set. So I'll say right off the bat, so a CSV file is just a type of file that we can read into Python. There's other types of files you can read into Python, as I mentioned. Basically, like, the first step of any analysis, if you're going to use Python or R or any software whatsoever, is to get your data into that software and make sure that your software can understand some basic things about that data or can interact with that data in the way that you want. And there are a bunch of Python libraries that we can use to work with data, and those Python libraries kind of assume that our data is in a particular format. So like pandas and NumPy and Matplotlib and Seaborn, if you've heard of any of these, they're really easy to work with if you have data that is saved in a data frame, which is essentially just this, like, this structure where you've got your rows and your columns. Each of the columns has a name. Your rows also have a name. By default, they're just going to get named with the numbers starting from 0. So you'll see when I print this out, I'm just getting some bolded row names and column names. And then I've got each of my rows of data. So, okay. First thing I'm going to do, or first thing I've already provided code for, is just reading this file into Python and saving it as something called heart. I could save it as something else, but I'm going to save it as heart, so I remember that this is my heart disease data. And this is, as background, this is a data set that is used, I think, in like a bunch of papers to essentially predict who is going to be diagnosed with heart disease. And so these are patients at a clinic who had a bunch of tests done, and then it was determined whether or not they had clinical heart disease, and this is all the information from those patients. And then what all I've done here, and I think this is all in the starting code, is I've just taken a look at the first 5 rows of the data. And here we go. So we've got, for each patient, we've got some information. We've got age, sex, CP. I've copied down the data dictionary here. So CP is a chest pain type. T-rest BPS, which is a resting blood pressure, a cholesterol level, an indicator of whether someone's fasting blood sugar is greater than 120, and then a bunch of other things as well. I won't go through all of them because we're going to look a little bit more in detail as we go through this. But you'll see right off the bat that there are some maybe weird things, or some things that just by looking at the data itself, you might not necessarily understand. So for example, in the sex column, we have numbers 1 and 0, it seems like. And we see, if we look at the data dictionary, that 1 equals male and 0 equals female. So we can figure that out. But maybe these numbers, as we're looking at the data, prevent us from like immediately gleaning something about the patient in this row. And so those are the types of things that we're going to look at in the next couple of steps. Okay. All right. So the purpose of today, I'm going to add another code chunk down here. So the purpose of today's lesson is really just to go through the process primarily of cleaning a data set. I know that data cleaning is not doesn't sound like the most fun. However, I would encourage you to think about this step as being kind of like a detective. We've got a pretty big data set on our hands. I mean, it's not huge we could have a larger data set, and in real life, people work with really big data sets. But you're kind of like a sleuth trying to figure out how you can best represent this information so that you can do something with it later. The other thing I'll say is I kind of want to start today with something that's not data cleaning, because I think it sets up the importance of these steps really, really well. So the first thing I'm going to do is I'm going to print out some summary statistics for this data set. I think it's equals all. I don't know if it's capitalized. Let's see. Oops. Oh, here's a good, okay, I should have said this before. A good thing to know is that you have to run this code. All I'm doing here is I'm importing some libraries that are going to help us with our analysis. So these are essentially like, they contain some of the functions that we're going to be using. They contain some of the tools that we need for our analysis. And I'm saving them as these aliases, which is just going to make it easier to reference them. I'm going to run it. I'm going to actually run this. So it's not saved from before. And now.
Yeah, if you look at that error message, it basically said it didn't know where heart was, because that was our data set that we never loaded in.
Yeah, exactly.
So Sophie, you said that we're going to look at summary statistics. What is a summary statistic?
That is a great question, Alex. Thank you for teeing me up so perfectly. Okay, so essentially talking through this process right now, step one is going to be cleaning up our data set. Step two is going to be figuring out some way to condense the information in our data set down to a smaller set of numbers or visualizations that we can actually make sense of. So in our data set right now, we have, for example, a whole long list of, let's say, ages. We have a whole long list of ages. And I think there's like 370 patients. So we've got like 370 ages. We can't really say much based on just like eyeballing those ages. So we want to condense that down into some sort of number that can give us some insight into what that column contains. And that's all a summary statistic is. It's a number that can summarize some information about one of these attributes that we have for a patient. Cool. And so you'll notice, and in our next live stream, we're going to specifically talk about some of these summary statistics and visualizations that could go along with them. But one thing I want you to notice is, so this describe function, it's like a built-in, essentially a method that's associated with data frames. So it's something that we can apply to any data that we've stored in this way. And it makes it really easy to super quickly calculate things about our data set, which is, super nice. That's why we use software like Python, is to be able to really simply, in one press of a button, get all this information about our data set.
So each one of these rows is a different summary statistic, where the mean is a summary statistic, the count is a summary statistic, the standard deviation, all these are, so each row is a different summary statistic for each column.
Exactly. Yes. I just saw in the chat, hi, Tongjin, one of my classmates, former classmates, is joining us. This is so fun. Okay. So anyway, one thing I want you to notice about the output of this is that this function is making some assumptions about our data. So for example, we pointed out before that sex was coded as ones and zeros. And now we look at this and we see that we're getting a mean for this variable. We're getting that like the mean of the sex variable, or the average, the mean is another word for average. If you're familiar, the average of the sex variable is 0.6798, whatever. That's kind of a weird thing to report. If you know how this variable is coded, you can figure out how to word that. You could say like they're like 68% of the people in this data set are male. You don't have to worry about how I know that right now.
CP is another good example where that's, if you scroll up to the description of CP, it's like 4 different types of chest pain. And so what does it mean that the mean or the average is 3.1, right? It's not like on average people have 3.1 level of chest pain. It's like, right, that's really hard to interpret.
Right, exactly. And then you'll notice over here, we have 2 other ones. So CA and Thal. So CA is a number of major vessels, 0 to 3. And so that actually should be a number. It should be a number 0 to 3. And if you look back at the data set or when we load it in, you'll notice that we see mostly numbers like 0.0, 3.0, 2.0. And yet, for some reason, it's not giving us a mean. It's not giving us that information. It's instead giving us this top row, which gives us the number of unique categories or unique values, and then the most frequent value and the frequency of that. So this is just saying that like there are 4 possible values of this. The number 3 is the most common of them, and there are 166 threes. And same over here, we've got 5 different values. 0 is the most common, and there's 176 zeros. And this is a way that we would usually summarize categorical data, so something like sex, where there's male and female. But yeah, it's being applied to something that we know based on looking at our data looks like numerical output. So that's kind of a weird thing. And we're not getting that for some of these other ones that we probably want that information for.
Right. Like for CP, we would like to know, hey, there's 4 different kinds. You're seeing 3 most often. Right. We don't care about the mean of CP. Whereas for this CA, we probably do care about it. Right. It's like almost even reversed where we want the numerical summary statistics, the summary statistics about how do I describe those variables? Not categorical. What's the opposite of categorical?
I would call them quantitative or numerical. Either is fine. Yeah. But yeah, exactly. So this is, again, still motivation for why it matters how our data is stored. But to summarize all of the summary statistics that we just looked at, my point here is that we have these built-in tools that can do things really quickly for us, but they're looking at how the data is stored and making some decisions about how to summarize them for us. And they're getting some things wrong. And that's because our data isn't stored in the way that it needs to be in order for us to use these tools to do our analysis. So that's why it's super important. Okay, the other thing that I'm going to take, so focus of the next 30 minutes then is going to be to look at how our data is stored and try to make sure that we make changes that we need to in order to store it in a way that will make our analysis more sensical. So in order to do that, the first thing I'm going to do is I'm going to take a look at the info about this data set. And the other thing I'll say is in Jupyter Notebooks, I like this. I don't have to use a print statement for the last line for it to actually print it out. Although if you're working in like a different IDE, like in order to get this to actually print, you'll have to do this.
Yeah, Codecademy, for example. If you're working
on
Codecademy, doing this stuff on platform, you'll need to explicitly say the print statement.
Exactly. Okay, so this gives us some information. Specifically, I think the most important column here that I'm going to look at is this D-type column. And the D-type column tells us what data type each variable is stored as. So this looks a little complicated, but basically all you need to know is that float and int are ways that numerical data is going to get stored. So if you see float or int, it means that it's storing it as a number. And that means that you can do number-y things with it. So you can like add numbers and subtract numbers and all the things that you would normally
find the mean,
that makes more sense. Yeah. So you can do a bunch of stuff with numbers. And so if you want to be able to do those things, then you need to store numbers as numbers. So that would be float or int. If you see, oh yeah, we've got an int down here. If you see something that says object in Python, this means that it's getting stored as a string. I think it's not worth going into right now why this gets printed as object and not something like string. But this is something, I don't know how it works in other programming languages besides R, but in R, you would see like that the data type is like str or string. But because of how data gets stored in Python, it's a little bit different. It gets stored in the memory and then with a pointer towards that memory. So anyway.
Yeah, but this is a good example of like why the summary statistics are being different. You can even see the two things that are being stored as an object or a string are the ones where it's able to do those first 3 rows, which was again the like the frequency count, the like types of answers, right? And it can't do all of the numbery things. It can't do mean, it can't do standard deviation, whereas the other ones are reversed. The things that are floats and ints can do all these number things, but then can't do the things that are associated with categorical variables.
Exactly. Yeah. So this is right here telling us, like you said, exactly why this whole business is happening. Okay. So now I think it's time to start trying to address some of these things and see if we can change how these variables are stored so that we can make more sense of this data. Everybody's saying that they're on like Python 5, Python 66. I think the highest is Python
3 is still like Python 3.7. So yeah, it was a big deal when they went from Python 2 to Python 3 officially.
Yeah, it's causing a lot of things to break. Okay, so the first thing I'm going to do is I'm actually going to go a little bit out of order. The first thing I want to understand, or the kind of the weirdest thing to me in this output, is that these two variables, CA and Thal, which I can see when I print out the data, seem to be numbers. Those are getting stored as strings. And that to me is like the most concerning thing that I see here. Or not concerning, but the most like unexplainable.
Obviously weird thing.
Because, Python is pretty smart. It looked at most of these and saw numbers and stored it as a number. So the question is, why is that happening? And so what I'm going to do to kind of investigate that. And the other thing I'll just point out, I know I'm scrolling up and down a lot, is that, so for CA, for example, it says that there's 5 unique values, whereas in our data dictionary, it said 0 to 3. So that would be 0, 1, 2, 3. That's 4 different. And same thing for Thal. There were 3 different values, 3, 6, or 7. I don't know why they chose 3, 6, and 7, but
I see what you mean about the like being a detective, where like we have our clue, right? We have like, wait, there's 5 things, but over here it only says there's 4 things. I would love in the chat, post your predictions for like what is this extra, like it's the case and the clue, like what is this extra value that's from this this variable that's screwing things up.
Yeah. And I feel like this is why I like statistics so much and data science so much, is that I like being a detective. Like I feel like if you can reframe your data cleaning as like an investigation, then maybe it feels more fun.
Yeah, yeah. The lesson here is data cleaning takes some some narrative behind it in order to be fun and exciting.
I'm trying to keep everyone. Ioannis, I hope I'm saying that right, is saying that the unique function will give us some clues. I agree with you, so I'm gonna go for that. Oops. So okay, so let me talk through what I'm doing. I've got the heart data set. I'm gonna pull out let's do CA first, the CA column, and then I'm gonna apply this unique function to that.
To just that column, because otherwise we'd look at every column and it would be confusing.
Ooh, yeah. And this makes some sense. So we've got, there's our 5 unique values. We've got a 0, a 3, a 2, a 1, and a question mark. And the question mark is our 5th value. And then I'm going to do the same thing for the Thal one.
Yeah, an interesting thing here is that you can even see that there's strings there. You can see the quotation marks around each of those values. And again, it's probably that, like in the CSV file, I bet there was no quotation marks, but because the question mark was also in there, it just forced everything to be a string because it didn't know how to interpret the question mark as a number.
Yes, exactly. Pierre says data cleaning is fun.
Yes, I agree, Pierre. I don't mean to make fun of data cleaning.
Love to hear it. Okay, so we've kind of answered our question. There was something that Python couldn't recognize as, I'm assuming, right, this question mark means that information wasn't available for that patient. And there's actually in Python, there's ways of indicating that something is missing, that like a cell of your data frame should be blank. And we need to make sure that we tell Python that so that it can so that we can change everything else to be like a number if that's what it should be. Okay, so with that in mind, what I'm going to go ahead and do is I'm going to replace all of these question marks with something that Python can recognize as missing. And I'm going to do that by using the replace method. So we've got heart.replace. And then we're going to replace, I'm going to just do this in the entire data set. So that'll do both of these at once. I'm going to replace this question mark with this np.nan. So np is just our like shorthand for the NumPy library, which is just a Python library that's used for data science. And then NaN stands for not a number. But it's just one form of missing data in Python.
Yeah, Ioannis brought something up, which is there's a couple of different ways to do this. Another thing that we could do would be to just drop those rows entirely, like removing them from the data set as if they never existed. I think let's walk through this way, but then I don't know if you can talk about like the differences in the two of like, because there's implications of like if we remove a row, then that's going to affect the other columns, like that's going to affect the mean of other columns.
Yeah, so actually I would say there like a whole other field of data cleaning is like what to do with missing data. And so there's lots of things you can do. You could delete that row. You could try to impute missing data, which means basically that you can try to like guess what that value should be in a way that doesn't affect the other data. So you can say like, okay, if we look at this row of the data, can we find other patients that look really similar to this person and what were their value here? So you could try to fill it in with something that at least is not surprising. So basically there's a whole field devoted to that. And I think that's a really good point. I'm glad you brought it up. But yeah. The other thing I'm just noticing, so when I do this, it's just printing it out. if I want to resave it, I need to do this. There's probably also like an in place equals true parameter, but I'm going to do this. So essentially, this prints out this data frame with the replaced values, but it doesn't change it in the actual
the thing that we're going to be using moving forward.
Actual data frame. So I'm going to go ahead and do this to actually save it. And now I'm just going to check really quickly this again, because my memory is that actually Python, it didn't change them.
So you were expecting, now that we've removed the question marks, that it would just auto change them all to numbers?
Yeah. Okay, I need to then, I don't remember actually the the syntax. This is a good example. So it didn't change them automatically, but we should be able to change them now. So we want to change them to integers or to floats. Actually, just
I think Ionis is right, where you can use the as type function.
Yes. I think, which one? So CA we want to change to a number. Thal, actually we want to change to, eventually we probably want to change it to these category names. So I'm just going to change CA for right now.
Cool.
Thank you, Ionis. As type, and then I'm going to just say, change it to int. I don't think I need to say int 64. I think that will just work, but let's try it. Oops, heart. Whoop. Let's try int 64. Sorry, guys.
Yeah, and it has to be a string.
Invalid. Oh, okay. I know exactly what. So because actually these got saved as values with decimal places, even though the decimal place is 0 for all of them, we can't save them as integers because they have that precision, or they have that decimal place. So we need to actually save them as floats. Whoop. And we're going to resave that as the as that column, and now this should work. Heart.info. Great. So now we've changed that. It said object before, now it says float, and so now we can interpret that column as a number.
Yeah, one thing to note here is in the chat, I posted the documentation for the as type function. I think Sophie and I just like talked it out here and also looked at chat to say, oh yeah, the as type function will probably do the trick. But I Googled, let's see, what was my Google term? Data frame change column type. And, the very first Google result was the as type function. And so that's like a good example of like, hey, we need to do this thing. We don't know how, or we don't remember how. And, that kind of stuff happens all the time.
Yeah. Yeah. My first like programming language for statistical analysis was R. So as I do more work in Python, I feel like I often need to search for things. But I think maybe the like side point I want to make here is that the important thing is that you know that you need to change this to a different data type. So in any programming language, if you understand that there's a data typing issue here, then you'll be able to figure it out in Google how to do like what's the exact syntax. So this is a perfect example of why like this is great to know off the top of your head, but this is like not the most important thing for being able to go through this analysis. Like the more important thing is conceptually understanding that this is something you should check and this is something that you should like fix if it's not right.
Nice.
Cool. Okay, so let's kind of go through. I think there are some other ones that are interesting. I'm seeing time on these live streams just goes by so darn fast. Like I don't even know. I want to make sure that we get through at least a couple more different examples, and you can look through the final code that I posted if you want to see kind of like a little bit more of what you can do. But let's pick something fun. So I think one of the things that is worth doing is for anything that's coded as a number, but it's really a categorical variable, especially a categorical variable where there's no order. So these are just like different types of chest pain. It's not like one type of chest pain is worse than the other. If that was the case, I would see more of a reasoning to maybe code something as 1, 2, 3, 4, where if it was like mild chest pain, moderate chest pain, severe chest pain, very severe, or something like that, then maybe you could leave it coded as a number. But since this seems to be unordered, I think you definitely want to change this so that Python can recognize so that Python can recognize that this is a categorical variable, and there's no like ordering or numbering. You shouldn't perform numerical operations on it. So let's go ahead and try to do that. I'm going to do that for the for the CP variable. And I'm going to just copy this over down below so I can use it as we go.
Sophie, I wonder, can you increase the size of your...
Ooh, yes.
Let's see. Hopefully that works.
Sorry, guys. That is something I definitely should have done.
No worries.
Okay, so I'm going to just do this one really fast. Okay, so we've got heart.cp.replace. I'm going to use a dictionary, which again, this is like Python syntax that you don't have to know right off the bat, but instead of just replacing all the ones and then replacing all the twos and then the threes and then the four, so I'm going to just pass all that information to Python at once. So I'm going to replace the value 1.0 with typical angina. While I'm typing this out, are there any like questions maybe that?
Yeah, let me take a look. We have a question of what is this? I can give a brief summary as you're talking about this. This is kind of a companion live stream to the new Master Statistics with Python skill path on Codecademy. This session in particular, we're looking to how to clean the data set, the different types of variables that you can have. So in particular, the thing that we're doing here is that we have something that's encoded as a number, but in reality, the data is an unordered categorical data type. And so we're changing that data type to be that right now.
Exactly. And I think this should work. I just want to check one more thing. So CP was getting coded as 1.0. Yeah. So it had decimals. Everything had decimals. Okay. Run that. And now let's take a look again at, I'm actually now interested, heart.info. Did that change it? Yeah, that automatically changed. That's interesting. So
that's because you just changed numbers to strings, right?
Mm-hmm.
Yeah.
Yeah. So, but in the other one, when we changed strings to all the numbers.
Well, it was we removed the question marks, but then we didn't say anything about all those other strings that were still sitting there.
Okay, fair. Okay, so yeah, we essentially replaced all these numbers with strings, and now this is getting stored as an object. And I'll just print out again. If I do heart.describe again, you'll see, oops, sorry, include all. You'll see that now we're getting different information about this variable. So before we got like a mean and a standard deviation and a minimum and all this stuff. Now we're getting that there's 4 different categories. The most common is asymptomatic, and there is 144 people who are asymptomatic. So that's great. That already means that we can we can do more with that variable. We can make sense of it. Cool. Let me think. Oh, I see a question about in place equals true. So essentially, I will demo this. So if I remove this piece and I run this code, it's actually just going to print out that column. So all that this does is it creates like a list of values that match up with that column, changing like all the ones to typical, angina, et cetera, but doesn't change it in the actual data that we have stored. And so there's two ways to kind of go about fixing that. I could just like save it on top of that column. So I could say like heart.cp equals heart.cp.replace. So I'm saying like, I want to take this column and I want to replace it with this column that we just created. Or I can say in place equals true, which just means that like, I don't want you to print it out. I actually want you to change the data set that I have stored in this way.
So sometimes the reason not to do it in place is if you're like just experimenting with the data and you don't want to completely forget about the original data. And like, you know, you still want to call this replace function, but you want to store it in some different variable and leave the original data unchanged. In place, I guess, is like slightly riskier because when you do it, the old data is replaced.
Yeah, you've now like wiped things clean. I almost always, actually, that's a good point. If I'm doing an analysis for real, I almost always don't do it in place the first time. I usually just like print it out to kind of do a gut check to make sure that it looks like what I expect. And then I'll go and I'll actually change the data itself.
Yeah. And as always, I mean, I was just saying like, oh, it's more dangerous. And as always, there's really nothing dangerous, right? It's not like you couldn't get that data back. The CSV is still sitting on your file in your computer. You could reload that data into another new variable. And now all of that original data is back into Python. You can do whatever you want with it. So yeah, I hesitate to say like, oh, this is dangerous because it's like, you can't screw up that badly, right? You can always reload the data from the very start and start over.
Yeah, exactly. That's true. Okay, I'm trying to quickly think through what are the best ones to go over in this last little bit of time that we have. I have two ideas. So one of the ones I think is useful to look at is the slope column. So this is a little bit of a stretch. I'm going to say that. I wanted in this live stream to at least have one example of an ordered category. And I'm not really sure if there is an ordered category in here.
Sure.
But I think slope is the closest to an ordered category, mostly because I did some research and I forget exactly which one was like good and which one was bad. But basically, I think
good, one was medium,
one was good, medium, and bad in terms of like what you would expect for this test. And so based off of that, I would say that there is some kind of ordering to this. Like it makes more sense to have like the upslope, no slope, downslope in that order versus like, and especially if that means like good, medium, bad, versus for some of these other ones, I don't see why it matters if something is in a particular order or not.
Yeah, I think the most common ordered categorical variable, or maybe you can correct me if I'm wrong about this, but like any survey that's asking you to rate something from 1 to 10, right? That's ordered. It's categorical because they're not letting you put in 5.56, right? You only have 10 categories to pick from, and 1 is worse than 2, which is worse than 3, and so on. And so we're trying to, yeah, I agree. It's a little bit of a stretch, but that's what we're looking for, where it's like these things go in some order and there's only categories.
Yeah, exactly. So for that purpose, sometimes, like I was saying before, if you have an ordered category, sometimes you want it represented in your data as both a number and a string. Like you want to know what the order of the categories is, but you also want to know what each of the categories means. Like in Alex's example, if it says like in a survey, rate your agreement, and it's like, don't disagree, or sorry, disagree, strongly disagree, neutral, agree, strongly agree, or whatever. If you're running an analysis, you might want to print out a plot where like you have those levels of agreement in order, because you want to understand like if someone agrees more with this, then how are they different by some other factor, or based on some other attribute. So you want to have that information, but you also want to know what it means. And in that case, there's a special data type that you can use in Python, and there's a special data type you can use in R. I think a lot of these sort of statistics language focused libraries or languages have something like this, where you can store data in both ways at once. So I'm going to demo that really quickly. We're running a little bit low on time, so I'm gonna actually just copy some code over, and then we'll talk it through. So the first thing I'm gonna do is I'm just gonna replace, just like we did before, I'm gonna replace the numbers with their definitions, and I'm gonna do it in place, even though it's bold decisions right now.
Now's the time for bold decisions with 5 minutes left in the live.
I know. and then I'm gonna also change this to a categorical data type. So I'm gonna specifically tell Python this is a categorical variable, and then I'm gonna give it the 3 categories, and I'm gonna say that this is ordered in this order. So upsloping comes first, flat comes next, downsloping comes third. And I'm going to also, I don't think I need to use in place equals true. It will automatically do that. Oh, actually, because I'm just resaving it as that column. That's why. I don't know why that, like, this bar appeared. Now I can't make it go away. Okay, so now I've saved this as this, this kind of dual variable type where I now have the labels. So if I reprint the first few rows of this data set, I'm going to see that that for slope now I've listed, I see like downsloping, flat, flat, downsloping, upsloping. So it's replaced it with these strings. But if I now say heart.slope .cat.codes, it's going to print out the numerical equivalents. So it's saying downsloping is it's numbering these from 0 upwards. So upsloping is going to get switched to is going to get the value 0. Flat is going to get the value 1, and downsloping gets the value 2. And so you'll see like downsloping got a 2, flat got a 1. That's why we have 2, 1, 1, then 2, and then 0 was upsloping. And so this just enables us to now work with those numbers if we want. And it also signals to Python for like plotting functions, for example. If we wanted to make a bar plot, I think it will now automatically, like before, it would order them alphabetically on the x-axis. Now it will order them based off of these numbers.
If we do the summary statistics now, will it do both the category ones and the numeric ones?
I don't think so.
Okay.
Also, another thing to note is that for ordered categories, like we still should not calculate the average of ordered categories. So that's still like not something that you should report. And I think to that end, it will not get reported, but we can try. We're almost out of time. But let's see. Yeah, so it's just printing the categorical variable ones.
Cool. So if you
I don't know, what do you think? Do we have time for one more? Probably.
Yeah, I mean, I can, if you want to go a little bit long, if you want to do another one, I can. Okay. I was going to say, I think this is also a good plug for the course itself, where you talk about like what can you do with categorical variables, what can you do with ordered stuff.
Yes. Yeah. I guess I'll skip the code, but I'll just talk like conceptually really quickly about one other concept that's useful. And so this, what I just showed with the cat.codes is one form of categorical encoding. And this is something that happens a lot when you want to like put a predictive model on your data or something like that, where a lot of models that machine learning specialist would try to fit on some data only can work with numerical data, or they can only work with numbers. They don't know what to do, or they can't operate with strings. And so a lot of times that means that you need to come up with some way to represent your categorical variables using numbers, which you can do, and which also makes it, I think, easier to analyze your data if you're just doing like an exploratory data analysis, which is to say that, there's multiple ways of doing this, and depending on what your ultimate goal is, you might do it in different ways. So here we had a ordered category, and we set this up so that we could easily translate that ordered category over to numbers. Another way that you could categorically encode a categorical variable is you could do something called hot encoding, which essentially means like breaking one categorical variable up into separate columns, where each column is just a 1 or a 0, depending on if it was that category, if it's in that category or not. And so like, just from a data analysis standpoint, I think an example of when you might want to do this is, well, actually, probably the best example of when you might want to do this is the last column of the data set, which actually has values 1, 2, 3, 4, and 0, where 0 means that there is no heart disease, so no presence of heart disease, and then 1 through 4 means that there is heart disease. And so if you're trying to build a model to predict whether someone had heart disease or not, and you don't care about the 1, 2, 3, and the 4, you might want to change that column so that you just represent, instead you just have one column and it's just like heart disease or not. And then it's going to be equal to a 1 or true or whatever you want if there is heart disease, and a 0 otherwise.
Right, rather than like 4 different designations of heart disease, which
exactly.
Which you might not necessarily care about.
Yeah. Okay, I'm going to leave it there. There's like a whole exercise about this on the lesson on Codecademy. There's code in the code that I posted. So if you want to play with it and you want to see how that looks, you should go for it and explore on your own. Post questions. You can post in the comments on YouTube even after the fact, and I'll take a look at things. I love to hear your thoughts. So.
Sophie, do you want to show the course super briefly to just show like the lesson in particular that aligns with this live stream?
Sure. Yes. So
I can also do it if you don't have a browser set up.
Let's see. You get to see my my setup.
Yeah.
On internet. Okay. Yeah. So this is the Master Statistics with Python path. And this is within variable types. This lesson on variable types is really the content that we just covered today. Also, the article as well has a little bit of it. Here's the stuff on hot encoding if you're interested in what you missed. Another thing I'll say is I recognize some of the names on the chat as people who have submitted bug requests or bug reports. I feel like this is a weird plug to submit bug reports, but I'm actually really grateful. Like Alex said, this course is kind of my baby, and I really want it to be good. And if you're confused about something, it probably means that somebody else is confused. And even if it's not just like, even if it's you don't understand, not that like something is really broken. If something's really broken, please tell me. But if you don't understand something, you can also submit a report or ask in YouTube chat or on our forums on Codecademy. Like, I really want to hear from you. And one of the weird things about this whole online education that like many of us are turning to, especially in the time of this pandemic, is that, I don't know, like I come from teaching in the classroom and you get this immediate feedback of how people are interacting with your content. And I really miss it. That's why I love these live streams so much. So if you want to provide that to me, that would be great. Cool.
Cool.
Anything you want to add, Alex? Or
no, we'll be back again next week, Tuesdays at 4, if you want to catch us live. Yeah. Sophie, do you want to do a 30-second plug of what we're doing next week?
Sure. Yeah. So next week, I'm going to pick a different data set because I feel like this data set is a lot, or it's like a little boring. So I'm going to pick a different data set and we're going to do some summary statistics and visualization. So we're going to try to look at some of the variables and visualize them and summarize them with numbers.
Cool.